This is a review of statistics. Question 1 asks us to say the type of correlation that's caused between the number of pages printed on a printer and the amount of ink that's used. So if we think about one is the X and one is the Y, we have the number of pages and the ink. As the number of pages goes up, the amount of ink that we use would also go up. Printing more pages does cause us to use more ink. So it is a positive correlation, and it is causal. Question number 2 asks us to describe a correlation that is not causal. The number of miles walked and the total calories burned is causal. As you walk more miles, you burn more calories. The population of a country and the census taken every 10 years. The population of a country changes, but it's not based on whether there's a census. The census counts the people, but the population of the country is caused by other factors, so that will be the correct answer. Let's check the final two. The number of hours the TV is on, the amount of electricity used, that is causal. The more hours the TV is on, the more electricity you use. And finally, the speed of the car and the number of hours it takes to travel a distance. Well, the speed of the car causes your amount of time that you take to travel. So that is a causal relationship. For question number 2, we're asked to find the mean and the population standard deviation for this data. So the first thing we'll have to do is put all of that information into our calculator. I did that to save a little bit of time. Under Stat, you're going to go to Edit and put all of your information in L1. Once you have all of your information in, you're going to click Stat and calculate the one variable statistics. In this situation, the mean is 9.455. The population standard deviation, let's go back and first eliminate 9.455. That rounds up to 9.46. So answer choice 3 and 4 are definitely not correct. Now to check the standard deviation, we're going to be looking for the symbol that looks like this. This is the population standard deviation. Looking at our list of values, the population standard deviation is 3.74. So we know the correct answer is choice 1. For number 14, we're asked to find how this data set will change if we add an additional player with a $10 million contract. We're asked to find the mean and the median and talk about how they will change. So on the left side, I'm going to write the mean and median before, and then afterwards I'm going to find the median after we add in that $10 million value. Once again, the fastest way to do this is going to be using our graphing calculator, especially because after we put in the data points for the first set, we'll just need to add 1 point in for the second. So we'll start by writing down all of the different data points. Okay, there are 24 pieces of data, so I know I've done that correctly when I see L125. Okay, once I put in all of my data, I'm going to calculate the mean and the median. The mean is the number shown at the top, so in this case 2.53, and the median is 1.4. Then in the data, we're going to add in one data point with a contract of $10 million. So we'll go back to Stat, and in our list at the bottom, we'll add in one more value with a value of 10. Again, we'll go back to stat and calculate our one variable statistics. So we'll see our mean has increased to 2.8. Our median is still 1.4. So we know in this case that only the mean will increase. The median will not increase. They don't both increase, and one of them does change. For question number 5, we're asked to find the spread of the data. The spread is not something that we typically need to use our calculator for, so let's just examine the data. Looking through, I see most of the data is between 60 and 70. There's 72, 79 are well above 70. 59 is below 60, but it's not that far away from the rest of the data. So first off, we can say it's not evenly spread because 72 and 79 are pretty far away from the rest of the data. The median of the data doesn't make sense. There's no way it could be at 59.5 because there's only one number that's underneath 59. 79 is definitely an outlier, and that's going to affect the standard deviation. We can say that the data is skewed. Skewed means it's not symmetrical, but that's because of 72 and 79. It's not because of 59. It's not because it's the only value below 60. For question 6, we're asked to create a frequency table. So we can go through each part of the table and see if it matches up. So we have two values between 61 and 70. Looks like all four options show two values between 61 and 70. There are 1, 2, 3, 4 values between 81 and 90. Sorry, like 5, 6 values. I was thinking to myself, something must be wrong there. There's 6 of them, so that's definitely answer choice 4. We can also verify there's 2 between 91 and 100, and there was none between 71 and 80. For question 7, we're asked to analyze a box and whisker plot. It asks what percentage of the people are age 15 or older. So if you know or remember, a box plot is separated into 4 parts. Each part represents 25% of the data. So if we look above 15, we'll see there are 3 pieces of data, each 25% each, or 3 quartiles, so a total of 75% of the people are above age 15. As a reminder, the line in the middle shows the median, so the median on this box plot is 7. The first quarter is shown at the beginning of the box, so the first quartile is 4. The third quartile is shown at the end, so the third quartile is 11. The range goes from our smallest number to our biggest. So in this case, the range is 12 minus 2 is 10, not 12. So that's why 8 is choice 2. For question 4, we're asked to create a marginal frequency, or find the marginal frequency or the joint frequency from a two-way table. In this case, it says, of the people who preferred burgers. So we're going to focus in on this part of the graph over here. How many people preferred burgers? Well, that's a total of 68 people, because 42 plus 26 is 68 people. It asks us to find what percent are female. So we're looking for 26 out of 68. If we do the division, that ends up being answer choice 2, 38.2%. For question 10, you'll notice that conveniently 100 students were surveyed, so our total amount of students is 100. They said that 60 of them watched sports, so that means if there's 100 total, that means 40 must not have watched sports. Of those 60 students who watched sports, it says 34 did not like pop music. So if there's 60 total and 34 of them don't like pop music, we know that must mean there are 26 students left who do like pop music. The last piece of information we're given is that of the students who do not watch sports, that's 40 people, 70% like pop music. So if we multiply 40 times 0.7, we'll end up with the number of students who don't watch sports but like pop music. And that is 28. That means that 30% of 40, so 40 times 0.30, will give us 12. and together those add to 40. We'll add across to find the total who like pop is 54, and the total who don't like pop is 46. Okay, next we're asked to create a frequency table and make a histogram. So as we go through each data point, we can add a tally in the appropriate part of the frequency tally chart. You'll know you've done it correctly if you have 2 values in the first interval, 2 in the second, 4 in the third, 6 in the fourth, and 4 in that last interval from 91 to 100. From there, we're going to create the x and y axes on our graph to make the histogram. We'll need to label. This is the test scores in Ms. Mosher's class. We'll have the frequency over here, and down below we'll have the test scores. We'll notice the first interval starts at 51 to 60. So I added 2 lines to show that we're not starting at 0. From there we'll keep our interval width the same as 3 wide. After that, we'll add in a space for our frequencies. So we're starting at 0. And going up to a total of 6. When you make each interval bar graph, make sure that you shade or color in a way that allows the different areas to be differentiated. For example, the first 2 both have a value of 2 frequency, so we want to make sure that we can clearly see those are different values. Alright, for our last problem, we're asked to create and find the values of the minimum, first quartile, median, max, and then make a box and whisker plot. So just like before, when you have a set of data like this, the best way to do it is to put it all into our calculator. As a reminder, you can clear out a list by going up and pressing clear. Alright, so for this data, we've got 35, 24, 32, 36, 40, 32, 40, 38, 36, 33, 11, 20, 19, 22, and 8. And again, there's 15 data points, so that makes sense that it says L116. After we've entered all of our data, we're going to go to one variable statistics and calculate. All the information we're looking for will be shown in the bottom part of our variable statistics. So we know our min is 8, our Q1 is 20, our median is 32, Q3 is 36, and the max is at 40. So if we go on our graph and start it at 0, going by 2's, we'll have plenty of room to get up to 50. Again, we said the min value was 8. We said that Q1 is at 20. We said the median is at 32. We said Q3 is at 36. And we said the max is at 40. We'll connect to make our box for the interquartile range and the whiskers to the minimum and the max. And we labeled all of the points. That's getting us full credit. Hopefully this is a helpful review of statistics.